Measuring half-life. Half-life is the time taken for half the unstable nuclei in a sample to decay. It is possible to measure the half-life of protactinium-234 in the school laboratory. Uranium decays to thorium, which then decays to protactinium-234. We use a polythene bottle containing uranium salts, and therefore also some thorium and some protactinium. When required, the bottle is shaken and the protactinium is washed out by the solvent present. Then, by placing a GM tube next to the solvent layer, the count rate can be recorded for about 5 minutes. Before doing this, it's important to find the background count, so this can be subtracted from the overall count, giving the count from the protactinium itself. Here we have a diagram of the apparatus. This is the polythene bottle containing the uranium salts and the solvent, which when shaken will wash the protactinium from the uranium salts. This then floats on top. The bottle is placed upside down with the Geiger-Müller tube placed above the bottle with a lead going to a scalar counter. We can then plot a graph of the corrected count against time, and we would get a line something like this. Noting the initial value and halving it, drawing a line across to the graph like this will give us one value for the half-life. We could then pick a different figure, for instance here, and find half of that, and this distance then will give another value for the half-life. They should be the same, but of course experimental uncertainty will mean they probably differ slightly. Picking a third value and halving it gives this distance, which will give another value for the half-life. If we then find the mean of these three figures, it should give us a fairly accurate value for the half-life. Of course, a better way would be to plot a graph of the natural log of count rate against time. The gradient then gives minus the decay constant, and the y-intercept gives the initial count rate. This is described in more detail on the video on radioactive decay rate.